Good afternoon, everybody. My name is Jacob Wright. I'm with Weatherford Geoscience, and with me is behind me Jason Dodd with Weatherford Managed Pressure Drilling. And today we're going to be discussing our strategy for drilling for carbon capture and underground storage. This drilling approach, it's like a three-prong discipline. We use our knowledge of subsurface and actual acquiring data and utilizing that. Formation evaluation data. We use drilling engineering and managed pressure drilling, as well as our digital platform to visualize the data and take a look at it real time and even for future wells for improvement and KPI monitoring. So in the carbon capture space, Weatherford is typically present in the storage and utilization. We have a technical portfolio that allows us to be involved in multiple assets of the well lifecycle, including from the beginning, well planning and drilling execution, to completions, to evaluation and monitoring, as well as even all the way through the abandonment phase as well. So we have a team of subsurface specialists that you can rely on for engineering, for formation evaluation, as well as engineering and planning for drilling and completions as well. And again, we have innovative technologies that we can link together all these different steps of the life cycle. So from a formation evaluation perspective, we look at the subsurface data and say, how can we utilize this? What can we do with this data to help improve efficiencies throughout the well life cycle? And there's many opportunities. Again, today we're going to be talking about the drilling side of things. This is one aspect of it, is utilizing formation evaluation mixed with managed pressure drilling and digital in order to improve efficiencies of drilling, understand formation properties, understand hazards that you might encounter while drilling, and mitigating those hazards through managed pressure drilling. And then, of course, learning from your KPIs, plotting the data, and having it be able to real-time evaluate it while drilling. So this is sort of the formation evaluation data that we look for when doing this type of evaluation. As you can see, we have reservoir properties on the right. You can identify resistivity, porosity, permeability, and we can use formation testing in order to get even better data with permeability and pressures and identified fluid sources. This is sort of the building blocks that we need to identify formation pore pressure and even fracture pressure as well, so we can identify a mud gradient window, right? We can get even more in depth with our cap rock, utilizing what we saw with the micro imager tool. We can see fractures, we can see smaller things within the formation, including even stress direction, and from a larger scale, we can see faulting, deformation, and other issues that might present hazards while drilling. And then, of course, if we have more advanced data like a shear acoustic or shear velocity, we can start looking at the mechanical rock properties of the well, try and identify trajectory during drilling, and understand those hazards there. So we take all this formation evaluation data and we try and use as much data as we can. So I mentioned last was wireline data. And I know in the early morning talk, we got to see some well filled out reports from older wells drilling. Those still can be very valuable to look at when doing this type of assessment, because it gives us an idea of what has happened while drilling. So not only do we look at the wireline formation evaluation data, but we look at previous reports, what people have seen in that area, such as influxes, such as losses while drilling, what mud weight they've been using. All that's valuable information to tie into our wireline evaluation. And if you look here, just another example of data that we can use. So here's borehole images that we saw. We saw some small features with cores. If you compare the core and imaging, you can even see even smaller features with core data. So you can get really small details with core, really good data, and you can also get really good data with seismic, but notice the range is pretty significant compared to wireline. We can combine all those, use core points for calibrations, and use seismic in areas we might not have formation evaluation data. We can try and correlate what little data we might have with seismic and use that as well to prepare. And so what we try and do is we prepare essentially a 1D geomechanics earth model, but we can do even lower than that and just identify pore pressure as fracture pressure and try and identify a safe mud window that we can use. This will help us identify casing depths, help understand the risks for drilling, and then also provide, again, formation properties and rock mechanical properties that we can use later on when we're looking at either injecting or producing a well, right? I'll hand it over to...
Cool. So, hello. For managed pressure drilling, simplify well architecture, reduce emissions, enhance production, reduce OPEX. Why that is and how that is well process safety. So basically, to start, all the wellbore comes through our MPD equipment through a dual choke manifold from the BOP through the choke and back to the rig, all in a closed loop system. So sour gas, high pressure events or anything like that could be mitigated on the fly without any environmental damage. So right here is our dual choke system. We have 2 of those for redundancy. So if one were to fail or something go wrong, we always have the secondary at the ready at all times. Downstream of that, we'll have what's called a mass flow meter, which is a real-time data gathering system. That'll tell us our pore pressure, frac gradients, and density of the wellbore. And we can add that on the fly. And that basically is what I just went through. But this here, that horseshoe-shaped gray thing there, that is our mass flow meter. So that'll be able to tell us everything from the wellbore and any back pressure and density we put back on it.
So utilizing managed pressure drilling is essentially sort of a precursor to well control. We have a very fast reaction time if we see any sort of influx or losses happening in the well that we can essentially eliminate and mitigate real time, right? The system that we have here is fast detection, fast reaction. Again, helping with mitigating these risks also reduces our loss in hole, so reducing the risk of losing a BHA in hole, and then also better hole stability and improved hole cleaning. That can help when we're looking at actually cementing the well, which is very critical for an underground storage, especially carbon capture, right? Is you get a better hole stability and that'll help with a better cement job as well. So this is actually an example where we've utilized this technique. It's hard to see all these numbers, right? But you can see there's 3 different stages. The uppermost formation is an upper Triassic formation that they really wanted to test. They wanted to get some formation testing done while drilling, right? And then this lower formation, you can't see this well, this little red line and blue line, that represents the mud window, and it's a very, very narrow window, right? So we identified this as a sort of a hazard that we have to control. You can see some areas where they might have some gas influx here. And so what we ended up doing was we identified this window. We helped our managed pressure drilling team to sort of prepare this plan. And then, of course, we drilled this well. And again, while drilling, we took both static and dynamic pore pressure tests. And we also took dynamic, I know I didn't write DFIT, so it was not confusing, but a dynamic formation integrity test. We did that while drilling, controlling the pressure on the backside. And it's sort of like a non-invasive test for the formation. We don't damage the test because we gradually increase the pressure during that test to whatever pressure we calculated for the formation. We can, if we see sort of a loss happening, we can abruptly stop the test and sort of prevent that formation from being damaged. So we can get a good formation integrity test without damaging the formation. This helps us understand when we set the casing, what pressures we can cement to, and when we run casing, right? So not only were we able to provide this sort of testing data with our customer, the first well we did with our managed pressure team, we did it 100 days quicker than a normal drill. The second time, so this is the second well we did, was we improved another 25 days drilling time. And we use our data to help us do that. So the third piece of this is our central platform, how we visualize this data while drilling, right? And this, what we're looking at here, is a lot of stuff you can't read, but you can plot offset wells. You can plot essentially this formation evaluation, this geomechanic model, real time. But what's interesting is you get this data, and whoever's looking at this real time, they can change what they want to view. It's not just a one presentation software. You have a drilling engineer that's focused on whatever documentation he wants to look at. You have directional looking at something. The geos and the petrophysicists are probably looking at formation evaluation data real time. People can take the data that's happening real time and look at it how they want. This helps us understand, the mitigation real time, but also we can use this to improve on the next well and plot those data sets while we're drilling the next well as well. So we have other technology that is in our portfolio for evaluation for casing and cement bond. We have surveillance with our Foresight Sense and Mars fiber optic cable for real-time monitoring over the life of a CO2 well. And then, of course, we have our abandonment team if for any reasons we need to abandon the well. So again, this approach allows for formation stability while drilling, allows us to improve KPIs such as cementing, improve drilling efficiencies, as well as lowering the cost of the drilling with lowering the NPT with any of these hazards and lowering the cost of the mud as well. And again, we focus on throughout the life of the well, so from exploration to offset evaluation, sort of the first key approach, managed pressure drilling, and then of course monitoring and this data set all throughout. Centro, you can monitor the next well and improve on what we did the previous one. So yeah, that's it for me. Thank you so much. Yeah.